1.
It's George, and I'm back again. And I'm here to talk about achrondrites. And it seems that's like supposed to be one of the rarest meteorites. Okay? And I'm going to show you what I know. Now, first, before I get started, I'd like to thank the people that are supporting me and understand, and anybody that has subscribed. I'd like to thank those people. Okay? There are people that are out there that are going to give me hell because what I'm showing people haven't seen before. That's why it doesn't make sense. And what I'm doing, when I'm talking, if you're thinking meteorite, you're going to expect to see meteorite. But if you're thinking space rock to meteorite, then you'll be able to understand and see what I'm talking about. And I'm going to show you something that people haven't been able to see because I haven't gave a real close-up. I'm going to do a real close-up of this. And I'm going to explain what I've discovered. All right. Now here's that normal rock that I cut in half. Okay? And you open it up. Okay? You get a close-up of it. This is metal, okay? But if you look behind it, right here, it's still rock and minerals. Behind that metal part is still rock and minerals. Okay, now why is it like that? Okay? Because the blade that was cutting it open finished converting what was in the inside that was almost ready to turn to metal. And you can tell by the blackness of the rock. Okay? This is what people don't understand. If a rock, when it coming in, it does not heat up enough or burn down all the way, it's going to be left like this. It will almost look like a rock. Okay. Now when we get here closer to the bottom part, if my looking up and my research and everything is correct, this is an achrondite. And this is what it looks like before it burns up into the little teeny pieces and fragments that everybody see. Now, this was whole. I cut it in half. If we go around the outside here, okay, and you look at all these little bumps sticking up, like that one. And this one right here. Now, this stuff right here, I'm going to take and I'm going to show you another rock that I have. And I believe this one to be an achrondite too, and I'm not going to cut it open just to prove a point. Because it's got a lot of the exact same characteristics. Now we'll pick this one up. We'll pick this one up. We'll go around and we'll look at it. We'll look at the spots on it. Look at that right there. Okay, that's embedded into the rock. And another thing is, this partial rock right here was green. This one had a green color on it too. But it's got a lot of this stuff on here. Look at that one right there. Okay? Look at that right there. There's just a lot of things sticking out on it, and it's totally different. Now, this one didn't get burned as much as this. You can tell the difference. But if you look at this side, right there, and you compare it to this side on the black one, it's the same thing. This is the same as that. Okay? But I don't want to cut this open if it's what I think it is. Because if it's what I think it is, it's better off as a whole rock. Okay? It is burnt. It is burnt. It did burn. But did it burn as much? I don't know if the rest had fusion crust on it, it wore off, or it just came in like that. Now people are finding it hard to believe that the mesosphere can fail, or there can be a problem in it. I'm trying to explain that there can be a problem in it. And some rocks will burn up, some rocks won't, some rocks will have a coating on it. And this has to do with how the mesosphere gets polluted with noctilucent clouds. It drops the temperature, and that stuff tries to put out the fire on the rocks while it's coming through. And it would make sense why our meteor showers are spread out. They're visible here, and then several months down the line, they're visible there, and then several months down the line, we have another one. Why we don't have consecutive meteor showers, one right after the other? It's because the mesosphere needs time to recover from the smoke. But, like I said, people are going to call me stupid, they're going to call me crazy. And they have that right. You don't have the right to watch. You don't have to watch this. You don't have to believe. I'm not forcing anybody to do anything. But if there's a problem there, like I think there is, and we don't address the situation, people could be in danger. This is the main point of all these videos I've been making. I've been trying to make people understand this. And the thing is this rock right here, the only way that you would know if it's a space rock is you have to test it. Testing it. You can't look at it and say it is or isn't a meteorite. You would have to test it and see what's on the inside. But going by what I know, and the experts and everything I've been looking up for the past 4 or 5 years, these rocks right here point to being achrondrites. Now, what achrondrite they are, I don't know. But see, nobody wants to believe anything I say. Nobody wants to take a chance, and nobody wants to come up here and do any tests. And if they did, it would rule it out, whether I am telling the truth or whether I'm not. And that's about all I can say. And you can take the rocks that I've shown, the last one that I just showed you, you can take and you can do that. You can compare that to other ones that have made it to the planet and burned a little bit and see some of the same similarities in it. I wouldn't lie to people and I wouldn't spread false information. It's all out there. All a person has to do is research it. But the main point of my videos is so they're out there. So if and when we have that problem and we got a lot of rocks coming through, somebody can go to that information. They don't have to sit there and look everything up to figure out what to do to be able to deal with the problem. It would be really helpful to almost be all the way there rather than have to spend a month looking it up while rocks are coming in and falling down on people and buildings and stuff. Okay? It's just common sense. And that's all I have to say.